Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे हमें केमिकल वेपर डिपोजिशन विषय रे पढ़िबा so we have already discussed about the various physical methods for the synthesization of nanostructure materials, and these physical methods in general require high vacuum and high temperature. Also they need expensive pumps and gauges and deposition chambers for their operation. That is why these methods are expensive methods for the synthesization of nano materials. Now since here the deposition takes place in ultra high vacuum chamber, so the purity of the end products can be obtained, okay, and these methods therefore lead to less contamination of the impurities. Now in case of chemical methods, here we can have synthesis of nanomaterials by chemical methods, which are actually a subject matter of this chapter, okay, and these methods include like that of your chemical vapor deposition, which is especially Mocbd, that is metal organic chemical vapor deposition, then the sol gel process, then electro deposition, hydrothermal synthesis, spray pyrolysis, colloidal synthesis, etc., okay, which work on temperatures lower than that of as required by the physical methods, okay. Further, there is no requirement of high vacuum chamber, and also in case of these chemical methods they are quite inexpensive, okay. So as a result these methods provide cost effective synthesis of nanomaterials as compared to that of your physical methods, okay. Now chemical methods are suitable for large scale production, and these methods involve simple techniques, but there are possibilities of foreign atoms or ions which are being adhered to the desired film or materials as impurities. Hence we can say more contamination here occur in case of your chemical methods than that of the physical methods, so it will result in less purity as far as the end products are concerned, okay. So this is the basic introduction. Now let us come to the subject today, the chemical vapor deposition, that is in short CVD, which is a bottom up approach, okay. So bottom up means from small materials having nano dimension will build up and will go or approach towards the bigger material, that is bulk size material, for the synthesization of nanostructure materials, right. So it is a chemical process that is used to produce high quality, high performance solid materials, okay. And in case of semiconductor industry, this CBD process is used for the production of nanofilms, then micro fabrication process, which are widely used the CBD technique in order to deposit the materials in various forms such as monocrystalline, polycrystalline, then amorphous and epitaxial, etc. And these materials include the silicon with oxide, carbide and nitride, etc. Then carbon, which is having fiber, nanotubes, then diamond, graphene, okay. Then we have the fluorocarbons, filaments, tungsten, titanium nitride and various dielectrics with high dielectric constants, okay. Now in case of this CBD process, the wafer, that is your substrate, is exposed to one or more volatile precursors, right, which react and or decompose on the substrate surface to produce the desired deposit, okay. This is what shown in the figure, okay. So you can see here in this figure This is the Cbd, that is chemical vapor deposition apparatus. So you can see in this figure, this is our substrate, and above this substrate we can have the deposition of the thin film by the process of chemical reaction and subsequent deposition. Okay, from this path we are transporting the reactant vapor, which is going in this way, okay, and being utilized in the chemical reaction and thereby coming out in this way. Okay, so this figure is quite simple. Now coming back, here the process of decomposition can be assisted or accelerated by using heat, plasma or other processes, and the form of precursor can be like that of your gas, liquid or solid form. Okay, now gaseous precursors are introduced into the chamber at normal pressures and temperatures, while that of your solid and liquid precursors, they require high temperature and or low pressures. Okay, now Cbd processing, here the temperatures are high, typically in the range of 850 to 1100 degrees Celsius, and in this process some of the volatile byproducts are also produced, okay, which are then removed by the gas flow through the reaction chamber. Okay, so the basic steps in the Cbd process can be summarized as follows. Number 1, formation of the reactive gas mixture, then mass transport of the reactant gas through a boundary layer to the substrate, then adsorption of the reactants onto the substrate, and finally reaction of the adsorbents to form the deposit. Okay, now some of the precautions which are required in case of this Cbd technique are pre-treatment of the substrate, then the reaction chamber must be clean enough, leak tight and free from dust particles and moisture. Okay, most commonly used metals in case of this Cbd coatings are like nickel, tungsten, chromium, titanium carbide, etc. Okay, now let us see some of the uses and applications of this Cbd technique. It is actually suitable for large area thin film deposition and used for corrosion and wear resistance, and also applied on the materials to acquire specific properties. Okay, Cbd is used to deposit high quality films and augment substrate surfaces in ways which cannot be done by the traditional surface modification techniques like that of your electroplating, painting, etc. Now it is extremely useful in the process of atomic layer deposition, that is ALD, for depositing extremely thin layers of material. Okay, so for example GaAs, that is gallium arsenic films, which are deposited by this technique, that is the Cbd technique, which are used in some ICs, that is integrated circuits, and also photovoltaic devices. Okay, similarly the amorphous polysilicon which are prepared through Cbd is also used in photovoltaic devices. Then polymerization by Cbd will allow for super thin coatings which possess some very desirable qualities such as lubricity, hydrophobicity and weather resistance. Okay, thus we can say Cbd has wide range of applications like that of in case of your electronics, then optoelectrical, photovoltaic, chemical industries for depositing coatings and to form foils, powders, composite materials, then free standing bodies, spherical particles and filaments, etc. Okay, now moving further, let us classify the Cbd processes. Actually, the Cbd processes have the variants which depend upon the way in which the chemical reactions are initiated. So accordingly, we can classify the Cbd techniques as follows. First, on the basis of the operating pressure. So according to the operating pressure range, it can be classified into three types. Number 1, atmospheric pressure Cbd, that is in short APCBD, where the Cbd film deposition occurs at the atmospheric pressure. Then low pressure Cbd, that is LPCBD, where the reaction and deposition occurs at subatmospheric pressure. Due to reduced pressure, the unwanted gas phase reactions are reduced in this case, which improves the film uniformity across the wafer. Then the third one is the ultra high vacuum Cbd, that is UHCVD, which is performed at extremely low pressure, typically below 10 to the power minus 6 Pascal, that is equivalent to nearly 10 to the power minus 8 torr. Okay, now of the above mentioned three types of CBD, the most widely used is the LPCBD, that is the low pressure CBD. Okay, now the second category of classification is according to the physical characteristics of the vapor, so that we can have number one, aerosol assisted CBD, that is AACBD, where the precursors are transported to the substrate by means of a liquid or gas aerosol, which can be generated by ultrasonic methods, and this AACBD is suitable for use with non-volatile precursors. And the second one is the direct liquid injection CBD, that is DLI CBD, where the precursors in the liquid form are there and the liquid solutions are injected to the vaporization chamber towards the injectors. Okay, the precursor vapors are then transported to the substrate, and this technique results in high growth rates. Okay, now the third type of classification is on the basis of the method of substrate heating. Okay, so we can have also two types in this way. Number one is the hot wall Cvt, where the chamber is heated by the external power source and the substrate is heated by radiation from the heated walls of the chamber. And the second one is the cold wall Cbd, where the substrate is directly heated either by induction or by passing current through the substrate itself, and in some cases the substrate is heated by directly placing a heater in contact with it. Okay, so here the walls of the chamber are maintained at room temperature. Okay, now coming to the fourth one is the plasma Cbd. Okay, so in case of plasma Cbd, the reaction is activated by plasma at a temperature between 300 to 700 degrees Celsius. Okay, these are further divided into three types. Number one is microwave plasma assisted CBD, that is MPCBD. Okay, here the substrate is exposed to one or more volatile precursors, and in presence of microwave induced plasma this is done. Okay, now these precursors react or decompose on the substrate in order to produce a deposit. Okay, now the second one is the plasma enhanced CBD, where it utilizes the plasma to enhance the chemical reaction. That is why plasma enhanced. Okay, so it enhances the chemical reaction rates of the precursors. Now this PECVD processing allows the deposition at lower temperatures, which are required for manufacture of the semiconductors. Okay, now the lower temperatures are also allowing for the deposition of organic coatings such as plasma polymers, which have been used for the nanoparticle surface functionalization. Okay, now the third one is the remote plasma enhanced CBD, that is RPE CBD, which is quite similar to the plasma enhanced CBD, except with the difference that here the water substrate is not directly in the plasma discharge region. Okay, so here only one of the reactant gases are plasma excited and the processing temperatures are kept low, even up to room temperature. Okay, now moving further, the next category of classification is the atomic layer CBD, that is ALCBD. Okay, and this technique deposits successive layers of different substances in order to produce layered crystalline films. Okay, so here the ALD reaction will break the CBD reaction into two half reaction, keeping the precaution material separate during the reaction process. Okay, the next one is the combustion chemical vapor reaction, that is CCVD. Okay, so it is an open atmosphere flame based technique for the deposition of high quality thin films and nanomaterials. Okay, also it is known as flame pyrolysis. Okay, the next one is the hot filament Cbd, that is HFCBD, which uses a hot filament to chemically decompose the source gases, and this process is also known as catalytic Cbd. Okay, so here the temperatures of the filament and the substrate are independently controlled, and this allows colder temperatures for better adsorption rates at the substrate and higher temperatures which are required for decomposition of precursors to free radicals at the filament. Okay, now the next one is the hybrid physical chemical vapor deposition, that is HPCVD, and this process involves both chemical decomposition of precursor gas and vaporization of a solid source. Okay, hence it is a thin film deposition technique which combines the physical vapor deposition along with the chemical vapor deposition. So it is a combination of both physical and chemical vapor deposition processes. Now the next one is the metal organic chemical vapor deposition. Okay, so later on we will read it in detail about this. So it is also called as Mocbd in short, and this technique here the organometallic substances are used as the precursors, and it can be used to grow thin films of materials, and it is also called the vapor phase epitaxy, that is MOVPE. Okay, now the next one is the rapid thermal Cbd, that is RTCVD, which uses heating lamps and other methods to rapidly heat the substrate, and in the thermal Cbd process the reaction is activated by a high temperature which is above 900 degrees Celsius, and thereby heating only the substrate rather than the gas or chamber wall, which helps to reduce the unwanted gas phase reactions which can lead to particle formation. Okay, so growth of uniform thickness film occurs in this process. Now the next one is the photo initiated Cbd, that is PICBD, and in this process we will have the UV light, that is ultraviolet light, which has sufficient photon energy in order to break the chemical bond in the reactant molecules, and it is used to stimulate the chemical reactions. Okay, and it is similar to the plasma processing, given that the plasma are strong emitters of UV radiation, and under certain condition the PICBD can be operated at or near atmospheric pressure, and the deposition occurs at room temperature. Okay, now coming to the next one is the characteristics of Cbd coating. Okay, so we will have following characteristics. Number one, it is fine grained, then impervious, that is not allowing fluid to pass through it. Okay, so it is impervious. Then high purity is maintained in this process. Then it is harder than similar materials which are produced using conventional ceramic fabrication processes. Then finally Cbd coatings are usually only a few microns, that is 10 to the power minus 6 meter, mane 1 micrometer. Okay, so few microns of thickness, and they are generally deposited at fairly slow rates. Okay, now we have the Cbd apparatus. So a typical Cbd apparatus actually comprises of gas supply system, deposition chamber, and an exhaust system, and the main components are as follows. So number one is the gas supply system, which is required for the supply of precursors to the reaction chamber. Then the second one is the reactor chamber, and this is actually the chamber within which the deposition of the film takes place. Then the third one is the substrate loading mechanism, where it is a system for introducing and removing substrates, mandrels, etc. Okay, then the fourth one is the energy source, which provide the energy in form of heat for the reaction or decomposition of the precursors. Now these energy sources can be like that of your tube furnaces, halogen lamps, induction heating, and lasers, etc. Now the next one is the vacuum system, which is used for the removal of all other gaseous species other than those required for the reaction or deposition. Then we have the exhaust system, which is used for the removal of volatile byproducts from the reaction chamber. Then finally we have the process control equipment, which are like your gauges, controls, etc., in order to monitor the process parameters, which are like your pressure, temperature and time, etc. So for this purpose we can have alarms and safety devices which are included in this category. Okay, now the next one is the precursors. So what do we mean by precursor? Actually it is a compound which participates in the chemical reaction and thereby produces another compound, so it is called a precursors. Now we know that materials are deposited from the gaseous state during the chemical vapor deposition process. So the precursors for CBD processes must be volatile, but at the same time they must be stable enough in order to be able to be delivered to the reactor. Okay, so generally the precursor compounds will only provide a single element to the deposited material, with others being volatilized during the CBD process. Okay, and in some cases the precursors may provide more than one element. Okay, so such materials simplify the delivery system as they reduce the number of reactants to produce a given compound. Okay, so let us have the CBD precursor material which fall into a number of categories as follows. These include hydrides, halides, metal alkyls, metal alkoxides, metal dialylamides, metal diketonates, and metal carbonyls. But besides these, a range of other metal organic compounds, complexes, and ligands may be used as precursors in this CBD technique. Okay, so what are the materials which are produced by the CBD processes? Actually, the chemical vapor deposition, that is the CBD technique, is extremely versatile process which can be used to process almost any metallic or ceramic compound. So it can produce elements, metals and alloys, along with that carbides, nitrides, oxides and intermetallic compounds, etc. Okay, now let us have a detailed idea about the metal organic chemical vapor deposition, that is MOCVD. Okay, so it is the metallo organic vapor phase epitaxy, that is MOVPE, which is also known as organometallic vapor phase epitaxy, that is OMVPE, or metallo-organic chemical vapor deposition, MOCVD, and it is a chemical vapor deposition method which operates on a principle which is similar to that of the molecular beam epitaxy, that is MBE, and this method is used to produce single or polycrystalline thin films. Okay, so the apparatus of this MOCVD is quite different from that of the MBE, that is the molecular beam epitaxy. Now this MOCVD is generally conducted using a quartz tube furnace with a heated substrate, and this is much less expensive setup than that of your molecular beam epitaxy. So the basic experimental setup of this MOCVD is shown in this figure. As you can see, this is the in way of the carrier gas, where it is going to the bubbler which is containing the precursor, right? Then it is coming out towards the heated quartz tube reactor which is containing the substrate, and it is coming out as a vent. Okay, now the benefit of this MOCVD setup is that here we do not require any turbo pumps, vacuum chambers or load locks, then EELS, that is electron energy loss spectroscopic guns. Okay, then other components which are used in the molecular beam epitaxy technique. Okay, in contrast to the MBE technique, here the growth of the crystal is by chemical reaction and not by the physical deposition method, right? Now the metal organic compounds such as trimethyl aluminum, then trimethyl gallium, trimethyl indium, as well as gases like that of your phosphine or arisen can be introduced into the heated reactor and allowed to decompose, giving the desired elemental species. Okay, and if the precursor are in liquid form, then the compound is brought into the gas phase by bubbling a carrier gas such as like that of your helium through the compound and allowing the gas to carry small amounts of precursors into the reaction chamber, as you have seen in the figure. Okay, so here no vacuum is required, rather instead we have the whole process which is taking place at a pressure of about 10 to 760 torr. Okay, so like MBE, in case of MOCVD, it can be used to grow thin films of materials, and this technique has also been used in the synthesization of semiconductor nanowires in the presence of gold nanoparticle catalysis. Okay, and this technique is preferred for the formation of devices which are incorporating the thermodynamically metastable alloys. So it is also used for the manufacture of optoelectronics. Okay, so this is something about your MOCVD, that is metal organic chemical vapor deposition. Now let us see what are the advantages. Number one, it will have faster growth than that of the molecular beam epitaxy, so it is around few microns per hour the growth rate. Okay, then the second one, it will have higher temperature growth, that means the growth process is thermodynamically favorable. And the third one, the deposited layers will have a quality which should be better than the MBE. Okay, but however, one of the potential disadvantage of this technique is the uniformity of the resulting films or the deposition of the materials. Okay, so this is because the flow of the gases above the substrate may not be completely uniform. That is why we should always consider ways to find a better control over the flow and subsequent distribution of the precursors over the substrate. Okay, and further, it has also a major disadvantage of involving toxic gases which are to be handled with care because it may have serious concern. Okay, so finally let us see the thin film deposition methods, which are broadly classified into two categories. Number one is the physical method and number two is the chemical method. In physical method, we have the physical vapor deposition, that is PVD, then laser ablation, molecular beam epitaxy MBE, then sputtering, that is RF or radio frequency, magnetron or ion beam. Okay, whereas in case of chemical methods, we have the gas phase deposition or liquid phase, that is solution deposition. Gas phase deposition is further classified into the chemical vapor deposition CBD, that is what we have read today, and the second one is the atomic layer epitaxy ALE. Okay, and here liquid phase or solution deposition is classified into four types. Number one is spray pyrolysis, then sol gel, then spin coating, and then deep coating. Okay, so these things we will read further in the upcoming classes. So physical method are expensive but relatively more reliable and reproducible. Okay, and most of the chemical methods are although cost effective, but their full potential for obtaining device quality films has not been completely explored in many cases. Okay, so this is what I have taken from one book about the chemical vapor deposition. Now you can see this is what I have taken from another book where it has given about the chemical vapor deposition in a brief manner. Okay, so I advise you to read it also, and by combining from both the books you make your note accordingly. Okay.
Thank you.